Welcome to our lesson on the law of exponents for multiplication. This law states that when multiplying powers with the same base, we add the exponents. Let's understand this with a simple example. Consider 2 powers of 2. 2 cubed times 2 to the 4th power. Let's expand this to see why the law works. When we multiply these together, we're actually multiplying 7 2's together. This gives us 2 to the 7th power, which is exactly what we get by adding the exponents 3 plus 4. Let's look at different scenarios. First, with positive exponents, 3 to the 2nd power times 3 to the 5th power equals 3 to the 7th power. When one of the exponents is 0, remember that any number to the 0 power equals 1. For example, 5 to the 0 times 5 squared equals 5 squared because 5 to the 0 equals 1. The law also works with negative exponents. Remember, a negative exponent means we take the reciprocal and make the exponent positive. For example, 2 to the negative 3 times 2 to the 5th equals 2 to the 2nd power. A common misconception is thinking you multiply the exponents instead of adding them. For example, 2 to the 3rd times 2 to the 4th is not 2 to the 12th, it's 2 to the 7th. Let's solve a practical problem. If you have 10 to the 3rd meters times 10 to the 4th meters, what's the result? Using our law, we add the exponents, 10 to the 7th meter squared. This is useful in physics and engineering calculations. To summarize, when multiplying powers with the same base, we add the exponents. This works for positive, negative, and 0 exponents. Remember to add, not multiply the exponents, and always check if your answer makes sense. Welcome to our lesson on the law of exponents for division. This law states that when dividing powers with the same base, we subtract the exponents. Let's understand why this works with a simple example. Consider the expression 3 to the 5th power divided by 3 to the 2nd power. Let's write out what this means using the definition of exponents. When we divide these expressions, we can cancel out 2 3's from the top and bottom. This leaves us with 3 3's in the numerator, which is 3 to the 3rd power. Notice what happened to the exponents. We started with 5 in the numerator and subtracted 2 from the denominator, giving us 3. This demonstrates the law. When dividing powers with the same base, we subtract the exponents. Let's look at some special cases. First, what happens when we divide by a number to the 0 power? Remember, any number to the 0 power equals 1. For example, 3 to the 4th power divided by 3 to the 0 power is just 3 to the 4th power, since we're dividing by 1. Now, what about negative exponents? When we have a negative exponent in the denominator, it becomes positive when we subtract. For example, x to the 2nd power divided by x to the negative 3rd power equals x to the 5th power. Let's practice with a more complex example. Suppose we have 2x to the 4th power divided by x to the negative 2nd power. First, we identify the exponents, positive 4 in the numerator and negative 2 in the denominator. Then we subtract. 4 minus negative 2 equals 4 plus 2 equals 6. Therefore, 2x to the 4th divided by x to the negative 2nd equals 2x to the 6th. Here are some common mistakes to avoid. Don't add the exponents when dividing. Remember to subtract. Don't forget to keep the coefficient when simplifying. And remember that subtracting a negative is the same as adding a positive. To summarize, when dividing powers with the same base, subtract the exponents. Remember that any number to the 0 power equals 1. And when working with negative exponents, subtracting a negative is the same as adding a positive. Practice these rules, and you'll master the law of exponents for division. Welcome. Today we'll learn about double exponents and how to simplify them. A double exponent occurs when we have a number or expression raised to a power, and that entire result is raised to another power. The rule for double exponents is simple. When we have a number raised to a power, and that whole expression is raised to another power, we multiply the exponents. Let's look at the general form. Let's start with a simple example. Let's solve 2 cubed caret 2. First, we identify that 2 is our base, 3 is our inner exponent, and 2 is our outer exponent. Using our rule, we multiply the exponents. 3 times 2 equals 6. So our answer is 2 to the power of 6. Let's calculate this. 2 to the power of 6 equals 64. Let's try a more challenging example. Let's solve x2, 3. Again, we multiply the exponents. 2 times 3 equals 6. So our answer is x to the power of 6. Now, let's try an example with negative exponents. Let's solve x moins de 3. The same rule applies. We multiply the exponents. Negative 2 times 3 equals negative 6. So our answer is x caret dash 6. Let's look at one final example with fractional exponents. Let's solve x un demi 4. We multiply the exponents. 1/2 times 4 equals 2. Therefore, our answer is x squared. Let's summarize what we've learned. When dealing with double exponents, first, identify your base and both exponents. Then, multiply the exponents together. The base remains the same and is raised to the product of the exponents. This rule works for all types of exponents: positive, negative, and fractional. Here's a practice problem for you to try. Simplify 2 to the power of 4, caret 3. Pause the video and try to solve it yourself. The answer is 2 caret 12, which equals 4096. Remember to multiply the exponents. 4 times 3 equals 12. Lesson on the power of product rule for exponents. This rule states that when raising a product to a power, we can raise each factor to that power and multiply the results. Let's solve an example problem using this rule. Simplify the expression 2x superscript 3y superscript 2. Let's break this down step by step. First, let's identify the parts of our expression. We have the number 2, x raised to the power of 3, a y raised to the power of 2, and all of this is being raised to the power of 4. Now, let's apply the power of product rule. This means we'll raise each factor to the power of 4. 4, 2. 2 equals 16 for x superscript 3. X superscript 3 equals x superscript 1 superscript 2 for y superscript 2. Y superscript 2 equals y. Let me explain how we got these powers. For x, when we raise x superscript 3 to the power of 4, we multiply the exponents. 3 times 4 equals 12, so we get x superscript 1 superscript 2. Similarly for y, when we raise y superscript 2 to the power of 4, we multiply 2 times 4, giving us y. Therefore, our final answer is 16x superscript 1 superscript 2y. To verify this is correct, we can check that. We raised 2 to the 4th power to get 16. We multiplied 3 by 4 to get the exponent of x. We multiplied 2 by 4 to get the exponent of y. Let's summarize what we learned. 1. When raising a product to a power, we can raise each factor to that power. 2. For variables with exponents, we multiply the original exponent by the outer power. 3. For numbers, we simply calculate the power directly. Here's a practice problem for you. Try simplifying 3a superscript 2b superscript 3 on your own. Pause the video, solve it, and then check your answer. The answer should be 27ab superscript 3. Did you get it right? To our lesson on the power of quotient rule for exponents. This rule states that when we have a fraction raised to a power, we can distribute that power to both the numerator and denominator. Let's work through some examples to understand this better. Our first example will be the fraction x squared over y, all raised to the 3rd power. To solve this, let's apply our rules step by step. First, we'll distribute the power of 3 to both x squared and y. In the numerator, we multiply the exponents. 2 times 3 equals 6. In the denominator, y to the 1st power times 3 equals y cubed. So our final answer is x to the 6th over y cubed. Let's try a more challenging example. Here's our second example, the fraction a cubed b squared over cd squared, all raised to the 4th power. Let's solve this step by step. First, we'll distribute the power of 4 to every term in both numerator and denominator. In the numerator, a cubed becomes a to the 12th, and b squared becomes b to the 8th. In the denominator, c becomes c to the 4th, and d squared becomes d to the 8th. Our final answer is a to the 12th times b to the 8th, over c to the 4th times d to the 8th. Let's look at one more example involving negative exponents. Here's our third example, the fraction x to the negative 2 over y to the negative 3, all raised to the 2nd power. Let's solve this carefully. First, we distribute the power of 2 to both terms. For x to the negative 2, we multiply negative 2 times 2, getting negative 4. For y to the negative 3, we multiply negative 3 times 2, getting negative 6. Our final answer is x to the negative 4 over y to the negative 6. Let's summarize what we've learned. When we have a fraction raised to a power, first we distribute the power to both numerator and denominator. Then we multiply the existing exponents by the outside power. This works for positive, negative, and zero exponents. Remember, this rule helps us simplify complex expressions involving fractions and exponents. To learn about the zero exponent rule and solve a problem using this important concept. Let's start by reviewing the zero exponent rule. The rule states that any number raised to the power of 0 equals 1. For example, x to the power of 0 equals 1, where x is any non-zero number. Now let's solve this problem. Simplify the expression y to the 7th power times y to the 0 power divided by y to the 10th power. Let's solve this step by step. First, let's apply the zero exponent rule. We know that y to the 0 power equals 1. Next, when dividing terms with the same base, we subtract the exponents. Here, we subtract 10 from 7. Our final answer is y to the negative 3rd power. This means 1 divided by y cubed. Let's review what we did. First, we applied the zero exponent rule, replacing y to the 0 power with 1. Then, we subtracted the exponents when dividing terms with the same base. Finally, we expressed our negative exponent as a fraction. This is how we use the zero exponent rule to simplify expressions. Remember, the zero exponent rule is a fundamental concept in algebra that helps us simplify expressions. Practice using this rule, and you'll find many expressions become much easier to handle. Welcome! Today we'll learn how to simplify expressions with negative exponents. Let's look at this expression. Y to the 7th times y to the 0, all divided by y to the 10th. Before we begin simplifying, let's review two important laws of exponents that we'll need. First, the zero exponent law states that any number raised to the 0 power equals 1. So y to the 0 equals 1. Second, the negative exponent law tells us that a negative exponent means we can rewrite the expression as 1 over the base with a positive exponent. For example, y to the negative n equals 1 over y to the n. Now, let's solve our problem step by step. First, let's apply the zero exponent law. Since y to the 0 equals 1, we can replace y to the 0 with 1. Next, when dividing expressions with the same base, we subtract the exponents. So y to the 7th divided by y to the 10th equals y to the 7th minus 10, which is y to the negative 3. Finally, we can apply the negative exponent law to eliminate the negative exponent. Y to the negative 3 becomes 1 over y to the 3rd power. Let's summarize what we did. First, we used the zero exponent law to simplify y to the 0 to 1. Then we subtracted exponents when dividing terms with the same base. Finally, we used the negative exponent law to write our answer without negative exponents. So our final answer is 1 over y cubed. Notice how we've eliminated the negative exponent by moving the base y to the denominator. Remember, whenever you see a negative exponent, you can always rewrite it as a fraction with the base raised to a positive exponent in the denominator. On fractional exponents. Today we'll learn how to solve problems using the laws of fractional exponents through some examples. Before we dive into our example, let's quickly review the key laws of exponents that we'll need. First, when multiplying terms with the same base, we add the exponents. When dividing terms with the same base, we subtract the exponents. And when raising a power to another power, we multiply the exponents. Let's solve this example problem. Simplify the expression the quantity x to the 1/2 power times x to the 1/3 power, all raised to the power of 2. Let's solve this step by step. First, let's use the law for multiplying terms with the same base inside the parentheses. We add the exponents 1/2 plus 1/3. Now, we need to add these fractions. To add fractions with different denominators, we need a common denominator. The least common multiple of 2 and 3 is 6. So let's convert each fraction to an equivalent fraction with denominator 6. Now we can add these fractions. 3/6 plus 2/6 equals 5/6. So our expression becomes x to the 5/6 power, all raised to the power of 2. For our final step, we use the law for raising a power to a power, multiply the exponents. 5/6 times 2 equals 10/6, which can be reduced to 5/3. Therefore, our final answer is x to the 5/3 power. Let's verify this is correct by looking at our work step by step. Let's summarize the key steps we used to solve this problem. First, we used the multiplication law of exponents to add the exponents inside the parentheses. Second, we found a common denominator to add the fractional exponents. Third, we added the fractions. Finally, we used the power rule to multiply the exponents when raising our expression to the second power. These steps will help you solve similar problems involving fractional exponents. Here's a practice problem for you to try. Simplify the expression the quantity x to the 2/3 power times x to the 1/4 power, all raised to the power of 3. Pause the video and try to solve it using the steps we learned today.